विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Today, we are excited to welcome Dr. Goutam Ghosh, a talented chemist and Ramanujan faculty member at the Center for Nano and Soft Matter Sciences, Bangalore, India. Dr. Ghosh has an impressive academic journey, starting with his MSc in Organic Chemistry from the University of Calcutta, followed by a PhD in Chemistry at the same institution. After completing his PhD in 2014, Dr. Ghosh embarked on a dynamic research career with postdoctoral fellowships at the Indian Association for Cultivation of Science in Kolkata and the WWU Munster in Germany. He also had a brief but impactful experience as a visiting student at the Department of Molecular Engineering, Kyoto University, Japan. Dr. Ghosh's work, particularly in the fields of organic chemistry and nanoscience, is making waves in both academia and industry. As a Ramanujan faculty member at CeNS, he is involved in cutting-edge research at the intersection of chemistry and nanomaterials.
For this, I am Dr. Goutam Ghosh. Actually, I'm a scientist here at CeNS, and basically I'm a chemistry background. And my specifically, if I say so, I'm background of organic chemistry. And recently, we are working on organic synthesis and peptides. So peptide is very important molecule, biomolecules, which actually we have in all our body, in all living systems. So with these, actually we synthesize in our laboratory of peptides, and we are actually making biomaterials for biomedicine application in future and all these things. Yeah. So these are our actually expertise for our lab. We are working now. I say about peptide, so you have to know that peptide is biomolecule, and each and every living system actually contains peptide. Okay, and our body contains a lot of protein. And what is peptide? Peptide is nothing but the precursor of protein. Like the small part of the protein is called peptide, right? And basically, our body synthesizes on its own. So with the enzyme and all these things. But so what we do, we generally synthesize with our all essential amino acids, 20 essential amino acids. So in our laboratory, we make it with the different chemistry. We are applying for that, and we are synthesizing in a solid state chemistry. It is called, actually. It is very well known also. In 1984, they got Nobel Prize for that also, this solid phase peptide synthesis. And the most important thing, what we do actually, so after synthesizing, then we actually try to make biomaterials out of this. And very interestingly, what I can say, we are making one molecule and we try to make biomaterials in a different dimensions. As for example, when we are making nanostructures, so these nanostructures are like 0 dimension, it can be 1 dimension, it can be 2 dimension, and it can be 3 dimension. And when actually it interacts with the biological system, it depends on the size and shape. As for example, if I say lock and key, if you say the same company lock, we cannot open with the same key, right? So there is some differences there. So size and shape is important for opening the lock. So it's the same thing. So our biological system have their own size and shape, and that is very important, because when we are interacting with the nanomaterial with the biological system, that is called nanobio interaction, and it depends on like size and shape of the system, nanomaterials, so that it can, like as for example, it can fit if it is a biological system, and if you see our nanomaterial and if it fits with the thing, then it will interact properly. That's why, so whatever we are, even for having drugs and all these things, all are actually nanobio interaction. So if a drug is not interacting properly in our body, it will not react, it will not actually work. So this is the thing. And now you are saying that how we can actually it will be beneficial for India.
In short term or long term.
Exactly, in the short term and a long term. You see, as I'm telling you, so this is a biomaterial. So obviously we are focusing on biomedicine, right? So it's a medical science and all these things. Simply, currently we are using with peptide biomaterial like piezoelectric material we are making. You know what is piezoelectric material? So if you give the mechanical stress, then it can convert into the electrical, or otherwise versa. If you give the electricity, and then it can transform into the mechanical stress, something like that. So as for example, if I'm telling you, people are using pacemaker, right? Yeah. So pacemaker has their battery and all these things. At certain level you have to change the battery, or you have to charge, something like that. But this is a hectic process, right? So people are like, again you have to go through a operation and a lot of parameters. But if we can make a material that don't need any charge and all these things, as for example, if you have pacemaker and then when we are walking, so it's basically actually it's a mechanical stress, right? This mechanical stress can actually transform into electricity, and that electricity can charge your pacemaker. But then why peptide? Why you are not using others, right? As I mentioned, peptide is biomolecules. It is already in our body, right? People are using peptide for drug. It can be drug delivery carrier, it can be direct drug. A lot of vaccines actually we are taking, that is directly people are using for the peptides. So in this way, we thought like this way. So it is still under process. Recently we have shown that how we can change the peptide nanostructure from single peptide molecule. We have changed the dimension, and from that dimension we showed that that dimension is not active for piezo, and but other dimension is active for the piezo. So in this way we can tune the nanomaterial as well as their property. So in future, now we have a plan to make a device so that we can go for this kind of application. I just gave one example for pacemaker, but if you see a lot of device nowadays we are actually introducing in our body for different purposes, right? So that needs like some charges or some other thing. So as peptide is already a biomolecule, so it will be biocompatible, because drug, we know the drug is a chemical, right? But all chemical you cannot have, because the drug should not be toxic for us, then only we can use. And peptide has the biodegradability, because after having, it can degrade in our body, and then it can excrete from our body also after uses. So in this way, actually our plan is to make this kind of biomedical device in future with the peptide based. So it will help us, and it will not be a adverse effect for the patient. So this is how actually our goal to contribute in, obviously in India, because you see India we are doing, especially for medical science, we are developing a lot. So I think in future also it will add to that development.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform, and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियां।